Yo, what is up, YouTube? It is your boy Big Stacks Broomy, and today I'm starting the first video in a long series of teaching you guys calculus. Now, I'm not going to start off with calculus. In fact, for this video, for the first episode, we'll be going back to the very fundamentals, to the very basics, some algebra you must have learned in middle school, perhaps at a very young age, very easy to follow along, and I guarantee that by the end of this series, you will be able to do some calci. Now let's go. So for this first episode, I will be going over the 6 primary types of functions you need to know in order to be successful in calculus. So to start off, first, let's define what a function actually is. Now often, uh, in your very former years of mathematics, you may have seen functions written as y equals x plus 6, right? But when we start getting up into higher level math, well, we don't want to note functions as y because it can get confusing depending on the kind of work that you're actually doing. So instead, we introduce the notation of an f. I know, very creative of us to call functions by f. But of course, this is just by convention. So we see in this first equation that we're given, we have y being equal to x plus 6. Now what does this mean? Well, it means that for any value of x that you put in, the result y will be whatever value you initially put in as for x plus 6. So, of course, this means that this would be the input of the function, and this would be the output of the function. Now, how can we note this so that we always know what our input is at the start of the equation, and then we're given the formatting for that input to then give us an output? Well, when mathematicians came up in the very former years of algebra, is that we would use an f followed by a parentheses with an x on the inside, and this of course being equal to f not being equal to, but the way you would read this is you would say f of x, and then you would then include an equal sign and whatever your function actually was. In this case, it was x plus 6. So this would be read as f of x equals x plus 6. And that would be our function in this case. Now that we've defined a function and its notation, what does all this notation and definitions, what do these terms actually do? So we can see that for that function we have an x in the parentheses, and I already established that this would be the input. Now you can visualize this in the sense that x is the input going into a function f of x, where this is our function, and it would output, and it would give you some output f of x. And actually for this case I can be a little bit more specific, that x would be going into x plus 6 and giving us the output f of x. So you can think of it kind of like a machine, you know. You put something into a machine, that would be your input x. It does whatever it does inside the machine, that would be your actual function, and then outputs a value. Now, what do we do with this input-output relationship? Well, this must mean that for some function, if we give a function a value, say a, then that means it maps, or if instead of x, we use some value in its domain, we call it a, and we run it through the function, and it would give some value f of a. Or we do another one, b, and that would also map out to some function b. Now for a function to be real, the function has to be one-to-one. Every value in the domain of x must satisfy the function and return an output. And I've already introduced a term here but this is where we start getting into the concept of a domain. And the correct term of this would be for all our values of x, we call this the domain of x, and all our outputs would be the range of our function. So it's often noted as negative infinity to positive infinity. And if you really think about what this actually means, negative infinity to positive infinity, is that not just every number? And this is often just written as a double line R, where this just means all real numbers. And this happens to be the domain of many functions. In fact, yeah, for most polynomial functions, this would be your domain. It's where you start getting into rational functions or that sort of thing where double line R starts to falter. So what does this actually mean? Well, if we were given a function, let's start using our notation here, x plus 6 perhaps, or the function that we just used. Well, we can put any number we want, any real number that we want into this function, and it will return a value. If we put in 2, we'll get 8. If we put in 4, we'll get 10. If we put in 1,000,000, we'll get 1,000,006. That's 100,000. Yeah. You would get 1,000,006. You could put any number you wanted into this function, and it would return a real value. So we would say that the domain for this function, the possible values of x you can have, is all real numbers, where this symbol just means element of, meaning that the values of x that satisfy this function right here are all real numbers. Any number satisfies this function. And this is one of the general ideas of the function. So to review, in this video, we introduced the idea of a function. We discussed the reading of the function. We found out that a function is simply a way of inputting values, numbers, and mapping them to outputs so that we can visualize how certain functions actually look. And we discussed domain, we discussed range, also being a subset of domain, and I did an example with a very simple function where we see that its domain is all real numbers, and although I didn't write it, we can also see that its range would be all real numbers just from the simple fact that it has no constraints dictating otherwise. So I hope you guys enjoyed this video. I'll be releasing another video going over the more in-depth realm of functions, going over some specific functions, a little bit more challenging than this, and however long it takes, we will eventually get to the point where we will be able to do some calculus. So hope you guys enjoyed. Maybe go get a dick to suck or something.